half-life. The time required for half-nuclei in a sample of a specific isotopic species to undergo radiative decay. The process by which the nucleus of an unstable atom uses energy by emitting radiation.
Alpha, beta, and gamma is a type of radiation. Alpha radiation consists of high energetic human nuclei. The range of the radiation in the air is only a few centimeters, and in water it is even lower. A normal sheet of paper would even be enough to shield from this type of radiation. The alpha particle will only penetrate the outer skin layer and will not reach the deeper, more sensitive tissue or internal organs. This means that alpha particle has less penetrating power. The beta radiation consists of an electron or positron which compared to alpha particle have a much lower mass. Therefore, the range in the air is up to a few meters. They can also penetrate deeper into the skin and emit their energy there, which means beta particle has more penetrating power than an alpha particle. Gamma rays are photons. They penetrate matter easily and ionize the surrounding atom as it passes through matter. The gamma ray has higher penetrating power compared to alpha and beta particle. They can pass through paper, aluminum, but cannot pass through lead.
Basically, there are three most common devices used for the detection of radiation. For example, the GM survey meter, the cloud chamber, and also the film-based dosimeter or film gauge. This is the GM meter. Next, the cloud chamber. Last but not least, the film badge.
How to detect a radiation? Radiation can be detected by the Geiger counter, which is the most common laboratory instrument. Geiger counter can detect all the type of radiation, which is alpha, beta, and gamma. So here's how it works. Geiger-Müller tube consists of sealed metallic tube filled with argon and bromine gases. When radioactive particles enters the tube, it ionizes an argon atom. Electron accelerated towards the metal wire, which is anode. The migration of the electron inside the tube results in an electric discharge. The counter registers the number of pulses and converts them into sound signals or display them as a measure on the screen.
Since some radioactive nuclei are more stable than others, they decay at different rates. A stable isotope will decay slowly, while the unstable isotope will decay in a shorter period of time. The radioactive decay measures the terms of characteristic time, the half-life. The half-life is the radioactive material with the time needed for the half-radioactive atom to decay. Radium-226, for example, has a half-life of 1620 years. This means the half-life of the given specimen Ra226 will undergo decay by 1620 years. In the next 1620 years, half the remaining radium decay, leaving only 1/4 of the original sample number of radium atom. After 20 half-life, only 1/1,000,000 of the original sample is left. Rate of radioactive decay will absolutely be constant, unaffected by any extra conditional. High-low pressure, high-low temperature, strong magnetic electric fields, and even violent chemical reactions has no detectable effect on the rate of decay of an element.